Okay, so we're going to do two more examples here with solving trig equations, and using our calculator. So we're going to find approximate values. And so the whole idea here is you want to look at this piece as a variable. So don't let the fact that it's a trig function confuse you. What we need to think is we need to think that it's the same as this and solve for y, but instead of y, it's a trig function. So I'm going to go ahead and put like terms together, which means that I need to subtract a 1 from both sides and work with this piece a little bit. So this one might end up being a little messy, but you're still just balancing the equation out. Okay, so I'm going to go ahead and move the 1 over. So that means if I subtract by 1 both sides, okay, so I get a -2 sine of theta, and we got this radical in here, so this makes it a little bit messy. -√3 minus 1. And then I'm going to subtract sine of theta here and subtract sine of theta here. And I'd get a -3 sine of theta is equal to -√3 minus 1. And then divide by the -3. And I would get sine of theta is equal to, and because all of these guys are negative, I can go ahead and turn everything into a positive. Okay, so I got sine of theta is equal to √3 plus 1 all over 3. And so now this guy looks messy, but we're just using our calculator. But before we even go on our calculator, I have to think about all students take calculus. So where is sine? This is a positive number. Got a few announcements going here, so sorry about that. And so because it's positive, we have two quadrants that we are positive in. So we're positive in the first and second quadrant. So when I find my angle, we need to understand that what I'm actually finding is the reference angle. So I'm going to do sine inverse of √3 plus 1 divided by 3, and just be careful with your calculator. So go ahead and crank out, and what I would recommend is crank out the √3 plus 1 divided by 3. So when we do that, you should get, and I'm going to approximate to the nearest thousandths, 0.910. And so now I put that in my calculator, and I get sine of theta, and that's equal to theta. Excuse me. I'm going to erase the sign here because it's not sine of theta equal to, it's theta is equal to 65.51 degrees. I rounded to the nearest hundredth. So this is my reference angle. Okay, so which quadrants, being positive, which quadrants am I in? So I have an angle in the first quadrant, 65.51, and I have a reference angle of 65.51 in the second quadrant. And so what are these actual rotations? Well, so this rotation in the first quadrant is going to be what I got on my calculator. So that's one of my answers. But quadrant 2 is going to be 180 minus the 65.51, and that is going to give me a 114.49 degrees. And so those are my two answers when solving this equation. Okay, so this one's a little bit of a challenge, and this is a good pre-calc problem. And you know, these are kind of hard if you don't really have the basis for the trick to this. But the idea here is ultimately to solve, sometimes, you know, we need to balance equations, sometimes we need to factor. So when we factor, we look for quadratics, or we look for a GCF. So the greatest common factor is sine. So what I'm going to do is I'm going to factor out a sine of x, and that leaves me with tangent x minus 3 is equal to 0. And now I have two factors. I have this one and this one. So I set both of these equal to 0, and I solve. Okay, so I have to know that I'm looking for this greatest common factor. Okay? And so I know sine of x at 0, these are the 2 points where sine of x is equal to 0. So my angle measurement is equal to 0 degrees or 90 degrees. And then now for the tangent one, I'm going to do tangent inverse of 3, and that's equal to 0. And I also need to determine, well, where is tangent positive? Tangent is positive in this quadrant and this quadrant. So I have a first quadrant and third quadrant angle. So to find quadrant 1, I just put it on my calculator, and whatever's in my calculator is my solution. So it's 71.56 degrees. Now for the third quadrant, I take the 180 plus the 71.56. And when I do that, I get 251.56 degrees. Okay, so once again, that is, so we have 4 answers, which is fine. All 4 answers will work. And a lot of times when you see 2 different trig functions, you're going to see that you're going to have 3 or 4 answers. We have to solve for each individual trig function, look for those greatest common factor ideas, and once you see it, I think it's one of those things, okay, now I know to look for that, but it might be kind of a hard problem. I think at first you might want to convert tangent to one of its identities, but that makes more of a mess. So looking for factors is a great way to approach some of these problems. Check for that work first. If that doesn't work, then move on to something else.